In this video, we're going to learn how to calculate the percent composition by mass of an element in a compound. We will also learn how to use this math concept to figure out what is the mass of an element in an actual sample. If we're given a formula weight right here, then we can figure out the percent composition by mass. If we're given an actual sample of that compound, then we can calculate the mass of the element of that sample. From our lovely little diagram here, you can tell that you can go to percent composition and then to the mass. So that would be two math conversions, or we can go straight from mass to the mass of the element. This initial mass is the mass of the compound, something sitting on a scale. Remember, formula weight is the ratio of mass to moles. All right, let's try a sample. Let's try to figure out the percent composition by mass of carbon in glucose. Glucose is a monosaccharide, and a percent is a ratio, so it doesn't matter the sample size. You just have to pick one. We will pick 1 mole as our sample size. Our equation for percent is always the same. It's part over whole times 100. The part and the whole have to have the same units, so they cancel, leaving you with the units of percent. So we had to define the part and define the whole, and typically the question will dictate what part we are talking about. Okay, so the question would ask about the mass of carbon in the mass of the whole compound of glucose. So the part would be just the carbon, and the whole would be all of glucose. So let's pick a sample size of 1 mole and see what we have. So I got the molar mass of the whole thing, added it all up, I got 180.18 grams per mole for glucose. And when I circle the one compound, I circled 6 carbons. So the part would be the carbon, but not one carbon, it's all the carbons in one molecule, or all the moles of carbon in 1 mole of the molecule, which is 72.06 grams, or 6 times 12.01. When you multiply this fraction times 100%, you get 39.99% carbon. The grams per mole will cancel, and you get a ratio of carbon to glucose, and then the units fall in of percent. Typically, these have fairly high sig figs because if you get them from the periodic table. So far is just had a compound, calculated formula weight, and we went down to percent composition by mass. Now, if we want to figure out the actual mass of carbon in a particular sample, then we'll do that and we'll add on one more part to it. We get the percent composition by mass, which is part over whole times 100%, or the fraction times 100%. We want to get rid of the percent, so we divide it by 100, and now we have just the fraction that is carbon by mass in the compound. The question would dictate some sample size, or if you're doing this in a lab, you would weigh this out. So picture a pile of glucose sitting on a scale that weighs 22 grams. All you have to do is multiply that by the fraction 0.3999 for carbon, and technically it's carbon per glucose, and then you'll get the mass of the glucose. Rounding to 2 sig figs, we get 8.8 grams of carbon in the glucose, in 22 grams of our glucose sample. So as you can see, we converted the molar mass into the fraction percent composition by mass first, and then we got the percent composition, took the percent out of it, and multiply the fraction times the actual sample to get the mass. However, There's a faster way if we're given the sample size initially and we want to know the mass straight there. It's a one-step process, really using the numbers we just had. Now, using the same numbers and the same sample size of the same compound, we're going to go straight from the sample size of 22 grams of glucose to grams of carbon. So what you do is you start off by doing simple conversions. We're going to put grams of glucose on top and then put grams of glucose on the bottom, except we're going to do grams per mole of glucose. In other words, we put the molar mass on the bottom. If you remember, the mass was 180.18. And on top, we're going to put the molar mass of the carbon. So we have the grams per mole of the carbon on top. I guess we could color coordinate that a little better. And that was 72.06 grams per mole of carbon, because remember, within the compound, there's 6 moles of carbon. So if you look at this guy right here is the fraction, and that fraction would be this number. If we divided these out, we get this number. Before, we multiply the 22 by the fraction to get the answer. Now we're literally multiplying and dividing it by the fraction itself, multiplying by the fraction. The answer will still be 8.8 grams of carbon, and we went straight there. So here's a question. A company isolated for 1,350 grams of gold-3 sulfide from an ore. An ore is just a mixture of typical metals and other compounds dug out of the ground. What is the percent composition by mass of gold in gold-3 sulfide? That's our one step. What mass of gold is in the sample above? You could do one additional step or just one step total. By crisscrossing the charges, I come up with Au2S3 from gold-3 sulfide. I wrote down the original sample, so I have that for later. For percent composition, we need part over whole times 100. The whole thing would be 1 mole of this, and the part would be 2 moles of gold because it dictates the gold. Adding it all up, I got 393 grams, 0.94 grams per mole of gold per 490.15. Then multiply times 100%. The grams per mole will cancel. You have a ratio of gold to gold sulfide, and you have the units of percent, and you end up with 80.4%. 80.37%. That is our answer for A. Now for B, we would merely get the 80.4% converted into 0.804, multiply it times 1350. In other words, this is going to be the fraction times the actual sample of gold sulfide. And this is going to be gold in gold sulfide, so these things will cancel out, leaving you with grams of gold. 1,090 grams of gold rounded to the 3 sig figs. If we didn't have this A question right here, and it was just what's the mass of gold in the sample, we wouldn't turn it into percent, multiply it by 100 only to take the 100 back out of it. I would go straight from mass of the gold sulfide, put the molar mass of gold sulfide on the bottom, grams per mole, Au2S3, and then multiply it times the molar mass of the gold in the compound. That would be 2 moles of gold per 1 compound, or 393.94 grams per mole of gold. The gold sulfide cancels, the grams per mole cancels, leaving you with gold and grams both on top, and therefore at this equal sign part here, we would end up with 1,090 grams of gold. I hope this video helped. Have a nice day. See you tomorrow.